After a rejected weld has been repaired, re-inspected, and found to be acceptable, the welding inspector should, letter A, change the original inspection report to indicate the part's acceptance. Letter B, mark directly on the part. Letter C, fill out a second inspection report. Letter D, tell the foreman to have the part moved to its next operation. Letter E, no further action is required. So this question pertains to what will the welding inspector do if a rejected weld has already been repaired and found to be acceptable. So letter A, change the original inspection report to indicate the part's acceptance. So maybe this can be done, but this is not the ideal action for this scenario. Letter B, mark directly on the part. So this may be done if the part to be repaired has not been re-inspected yet. So if it will be if it's yet to be repaired, the rejected weld has not yet been identified. Letter D, tell the foreman to have the part moved to its next operation. To have the part moved to its next operation is not an ideal action in this scenario. Definitely letter E. So you, as a welding inspector, you have to uh, at least document the acceptance of the re-inspected weld. So letter C is the best answer for this question since you the welding inspector feels or fulfills his obligation to document its findings by filling out a second inspection report documenting the results of the reinspection for the repaired welds. So this is the safe approach here to refill or to fill out a second inspection report to document how the repair weld has been inspected. Also, some standards like API 1104 requires inspection of repair welds by non-destructive testing or even visual inspections, and the records must be kept. So the answer here is letter C. A wire IQI is used in which NDE method? Letter A, UT, letter B, ET, letter C, RT, letter D, MT, letter E, PT. So IQI stands for Image Quality Indicator or penetrometers in the industry. It's also called pennies. So this is the device used to show the quality of the radiographs. So the material for the IQI needs to conform to a standard such as ASTM. And the specification for the whole IQI depends upon the weld thickness. So based from that, uh, it is a device to show the quality of the radiographs, meaning the answer here is letter C, radiographic testing. So if you're not familiar with the abbreviation or the acronym, so UT is ultrasonic testing, ET is eddy current testing, MT is magnetic particle testing, and PT is dipenetration testing. The performance of which of the following test methods is least affected by high part temperature? So this question pertains to what testing method is least affected by high part temperature. So basically, after the weld, you can expect that the base metals and welded the welded metal is subjected to a high temperature. So what testing method is least affected by it? So letter A, ET, letter B, RT, letter C, PT, letter D, UT, letter E, VT. So ET stands for eddy current testing and does not need for the probe to touch the metallic specimen. So ET is done by a coil carrying AC and works by electromagnetic induction. So because of this, hot parts are facilitated and allowed. But the limitation of this testing is that highly skilled operators are required to operate and interpret the results. So by that, ET is not affected by the high part temperatures of the weld and the base metal. So for the other choices here, RT uh, is the high part temperatures can affect the result, especially PT and UT because of the need of the contact of the couplant to the base metal or the welded part of the metal. You need to basically have the uh, base metal cool off a bit for safety purposes as well, and of course for visual inspection. So you need to have the metals cool off a bit. So the answer here is letter A. So since the eddy current testing doesn't need contact to the base metal or the metallic specimen, so this is the test method that is least affected by those high temperatures of the base metals. Crater cracks are most often the result of letter A, improper technique, letter B, improper filler metal, letter C, improper base metal, letter D, trapped slag, letter E, trapped hydrogen. So this discontinuity is often the result of improper technique because of improper termination leading to insufficient weld metal volume and rapid cooling, causing the shrinkage in the crater area. So the crater cracks are mostly a result of the improper termination of or the welding electrode in contact to the base metal, causing rapid cooling of that point or that area, causing shrinkage. So the answer here is letter A. So the improper technique of the welder most often results with crater cracks. So for the choices here, so what that's why they're not the correct answers is that filler metals in base metal does not cause rapid cooling. It depends upon the heat input. Trap slag causes uh, mainly causes slag inclusion, and trapped hydrogen can cause embrittlement and can eventually lead to cracking as well, but not crater cracks since it does not lead to shrinkage stresses, unlike the improper technique or improper termination that I've just mentioned earlier. So the answer here is letter A. The tail of a welding symbol should not be used for letter A, denoting welding process requirements, letter B, denoting welding procedure requirements, letter C, denoting welding electrode requirements. Letter D, denote welding specification requirements. Letter E, denoting groove angle. So this question pertains to what the tail of a welding symbol is not used for. So it can be, the question can be best demonstrated with this illustration. So this illustration, as you can see here, the groove angle is specified at the top of the weld symbol. This is the weld symbol at the center. So this is the groove angle. So as you can see here, the tail is used for specifying processes or other references. So it can basically specify drawing references, what welding process is it, or among others. Especially indicated here welding process requirements, you can indicate that in detail, even welding procedure requirements, or electrode requirements even, and welding specification requirements. This can be indicated in the tail. But the groove angle has a specified location in the welding symbol. So the answer here is letter E. So denoting groove angle is not a function of the tail of a welding symbol. Which of the following may not be detected with VT or visual testing? Letter A, large surface cracks. Letter B, undercut. Letter C, overlap. Letter D, underfill. Letter E, lamellar tear. So for the choices here, large surface cracks, undercut, overlap, underfill can be detected by visual testing because this can commonly occur in the surface or in the surface of the weld. So large surface crack obviously can be seen visually. Undercut can be seen visually. Overlap and underfills in the joint root can also be seen visually. But lamellar tear, you cannot see it. May not be seen uh, through the naked eye or through visual testing. It is a terrace-like fracture resulting from welding shrinkage, and the three main causes of this are stresses in the through thickness direction, which is parallel to the rolled surface, susceptible joint configuration, mainly for thicker metals. Uh, One of the reasons it may not be detected with VT because of the thicker metals, it may occur underneath the surface, and materials with high inclusion content. So eliminating one of those three causes can reduce the susceptibility of the metals undergoing lamellar tear. So the answer here is letter E. Which of the following elements are commonly used as alloying elements with tungsten to produce GTAW electrodes? Letter A, cesium. Letter B, thorium. Letter C, columbium. Letter D, vanadium. Letter E, chromium. So thorium aids in improving the electrical characteristics by making the tungsten electrode more emissive. So basically, it makes it more easier to initiate an arc for the TIG welding. So it is most commonly used for joining ferrous metals, hence why it is a common alloying element with tungsten. So if I'm not mistaken, so thorium is added, I think, 1 to 2% with tungsten to have this effect. So the answer here is letter B, thorium. So this is the most common alloying element in producing TIG electrodes. For single bevel groove weld symbols, the line of the weld symbol running perpendicular to the reference line is always drawn on which side of the weld symbol? Letter A on the right, letter B on the left, letter C on either side depending on company policy, letter D on the side in which the straight side actually appears in the joint, letter E doesn't matter. So this question can be best demonstrated by this illustration. So this is a groove, a single bevel groove weld symbol right here. So the line perpendicular to the reference line is this part right here. So the straight line coming through the reference line perpendicular to it. So it is always left of the welding symbol. So it is always left of this one, right? So it's always on the left part of the weld symbol. So the answer here is letter B. So it's always on the left side of the weld symbol. So the portion of the groove face within the joint root is called letter A, weld interface, letter B, faying surface, letter C, groove weld edge, letter D, root face, letter E, groove angle. So the joint root here is the shaded part of this figure right here. So this is where the root face, so this is the root face right here, and the groove face. So this entire shaded portion is the joint root right there. So basically, uh, the part where the groove face is within the portion of the groove face within the joint root is the root face, letter D. So as you can see here, this is the entire groove face, and this part here is the root face and the groove face. Basically, they are on the same joint root. The groove face is the face wherein the groove angle is located. So basically, this is the part of the groove face, this part right here. So the entire part of this one is the root face and the groove face. This is the part of the root face, basically. So the answer there is letter D, root face. Piezoelectricity is a material property used by which NDE method? Letter A, UT, letter B, ET, letter C, RT, letter D, MT, letter E, PT. So piezoelectricity is used in UT, wherein the transducer is attached to an electric base unit. The machine then produces pulses through a coaxial cable that is in contact with the test object through the use of a couplant, right? So for letter B, the choice here, eddy current does not make use of contact with the metal, unlike UT with couplant. Hence, it doesn't make use of the concept of piezoelectricity. So RT uses radiographic waves. MT uses magnetic field with ferromagnetic material. So you cannot use MT for stainless steels without the presence of iron. Those ferrous stainless steel, you can use it against that. PT uses the concept of capillary action, which makes use of the developer liquid rising through the crevices of the discontinuity or defect. So the answer here is letter A, UT.
Which of the following is considered to be part of the welding inspector's responsibility to the public? Letter A. Undertaking only those assignments for which the inspector is qualified. Letter B. Making public statements as to the quality of a weldment. Letter C. Signing for all inspections on the job. Letter D. Reporting all discontinuities. Letter E. Verify conformance based on past experience. So letter B is a choice not obligated with the welding inspector. So he's not obligated to make public statements as to the quality of a weldment. Letter C is a little bit too general, so signing for all inspections on the job. Again, it ties to letter A, for which the inspector is qualified. So letter D, reporting all discontinuities is not necessary. So an entity specialist will most likely do this depending upon his or her qualification. Letter E, verify conformance based on experience. So this may not exactly rely based on past experience, but the best statement here is that it must conform to the applicable specifications or standards. So the best answer here is letter A. Which of the following processes is performed primarily in the flat and horizontal positions? Letter A, SAW. Letter B, OAW. Letter C, GTAW. Letter D, GMAWS. Or letter E, SW. So if you're not familiar with the acronym, so letter A is submerged arc welding. OAW is oxyacetylene welding. C is gas tungsten arc welding. D is gas metal arc welding, short circuiting, and SW is stud welding. So of all the welding processes here, the only process that can be performed in a flat and horizontal position is submerged arc welding because of its bulky setup. So SAW is also a fully automatic process where a welding operator is assigned since most of the variables inputs are done by the machine itself. Also, the volume of flux deposited in submerged arc is so significant, even if you can configure the machine to do the overhead welding, the amount of wastage for the flux would be so much. So the answer here is letter A. A groove weld symbol with no information appearing to the right means letter A, the weld is to be completed. The weld is to be a complete joint penetration. Letter B, no weld is required on that side. Letter C, the weld is to be continuous for the entire joint length. Letter D, no weld joint preparation is required. Letter E, weld length can be determined by the welder. So it is best to answer this question by showing this figure. So as you can see here, the weld symbol is right up in the center here. So the weld symbol will appear mainly if the weld is on the other side of the joint or in the arrow side of the joint. So this is the center right here. So if you can see the weld length of the weld legend here, so it is labeled as L here. So this is the length of the weld. So if this is omitted, so the length of the weld can be assumed to be continuous for the entire length of the joint. So if you have, say, a joint that is 3 inches, then if this length of weld is not specified, then it is understood that the length of the weld is also 3 inches. So the answer here is letter C. The weld is to be continuous for the entire joint length.
By the way, I just want to take a break from the video and remind you of the free Udemy course that I've put in the description down below. So it composes of CWI Part A lectures, the introduction for welding inspectors. So you can check out the description below for that free Udemy course. Now back to the video.
The property relating to a metal's resistance to indentation is letter A, tensile strength, letter B, ductility, letter C, hardness, letter D, toughness, letter E, fatigue strength. So this question pertains to the material properties of the base metal. Letter A is the capacity of the material to resist a force normal or perpendicular to its cross-section. Ductility refers to the ability of the metal to be elongated without breaking. Toughness is the resistance of the material against impact, and fatigue strength refers to the capacity of the material to withstand repeated loads. So the answer here is hardness. It is the property relating the material's resistance to indentation. So the answer here is letter C. LT is the abbreviation for A, leak testing, B, liquid penetrant testing, C, liquid test inspection, letter D, lithium testing, letter E, Lender test method. So the answer here is A, leak testing. So it might be confused with liquid penetrant testing, but the abbreviation for penetrant testing is PT. Leak testing is the answer here. It is a kind of destructive testing that fills in the vessel or a pipe with a medium, commonly water. It may or may not be pressurized depending upon the testing requirements. Of those microstructural constituents listed below, the hardest is A, martensite, B, ferrite, C, bayanite, D, austenite, E, perlite. So this question can best be answered if you understand this iron carbon phase diagram. So the question is pertaining to which one is the hardest. So this is dependent upon the rate of cooling once the metal is heated. So you can see here perlite, austenite, and ferrite forming at different temperatures. So you can see here this the vertical part of the graph is the temperature. So depending upon their carbon percentage, so perlite and ferrite uh, forms at this range of temperature under these carbon percentages. So what about these choices? So perlite appears at a normal cooling rate, followed by bayanite at a faster cooling rate because the hardness of the metal depends upon the cooling rate in which it is subjected to, and martensite at very fast cooling rate. So typically through a quenching medium. So the faster cooling rates will produce a harder but a more brittle material due to the reduced grain structure. So the answer here is letter A, martensite. So the finer grain structure will be reflected on the material that has undergone a slower cooling rate. Basically, that is perlite. Then the more coarse grain structure is for martensite because of its faster cooling rate. That this constituent will almost always equate to a brittle material. Filler metal specifications are found in which of the following documents? Letter A, AWS A5.1 through A5.30. Letter B, ASME Section 2 Part A. Letter C, AWS A3.0. Letter D, AWS A2.4. Letter E, AWS D1.1 Section 2. For the choices, letter B pertains to the forms of ferrous material products. So that is ASME Section 2 Part A. AWS A3.0 refers to the standard welding terms and definitions. So if you need reference regarding the terms and definitions for welding, it is under AWS 3.0. AWS A 2.4 is for welding symbols, and AWSD 1.1 Section 2 is for structural welding code, and the design of the welded connections under that code. So the filler metal specifications are found in letter A, A5.1 to A5.30. The flux covering on an SMAW electrode produces which of the following? Letter A, gas shielding. Letter B, arc stabilization. Letter C, alloying. Letter D, deoxidation. Letter E, all of the above. The answer here is letter E, all of the above. So the flux covering on the stick welding electrode provides each of these characteristics. So the flux covering provides shielding, which prevents hydrogen from penetrating the molten weld puddle, basically preventing moisture to be captured in the molten weld pool. Arc stabilization, which maintains the arc. Alloying provides different elements in the weld metal, thus providing strength and additional material properties to its betterment. And the oxidation removes impurities, thus uh, improving its slag characteristics. So the answer here is letter E. The tensile test can be used to provide values for each of the following. Letter A, yield point. Letter B, ultimate tensile strength. Letter C, modulus of elasticity. Letter D, elastic limit. Letter E, all of the above. So this question can be best explained through a diagram right here. So as you can see here, the Young's modulus or the modulus of elasticity can be found here. The part wherein the stress and strain are still linear right here. Basically, the rise and run are in proportion to each other. And then as it reaches a point of somewhere below here, it is the elastic limit below the yield strength. After the yield strength or the yield point, the material will no longer elongate proportionally to the stress applied to it. And then it will go to its maximum or capacity or its ultimate tensile strength right here before it ruptured at its rupture point. All of these points can be determined in a tensile test because basically the material will undergo through this entire stress strain diagram process because the tensile test will ultimately break the material up to fracture. So the answer here is letter E, all of the above. Information that appears to the left of the weld symbol refers to letter A, weld length, letter B, weld size, letter C, electrode size, letter D, number of passes required, letter E, none of the above. So this question can be best explained as well with the diagram here. So the information that appears left of the weld symbol. So again, this is the weld symbol on the center of the welding symbol. So the parameter that appears to the left is the groove weld size or the size of the weld. So upon the choices here, so weld length appears on the right, so that's not appropriate or that's not the correct answer. So the electrode size you don't specify in the welding symbol as well as the number of passes. So the answer here is letter B, weld size.
A material's ductility is commonly expressed in terms of A. Percent elongation and reduction of area. B. Width and thickness. C. Tensile strength and yield strength. D. Toughness. E. Fatigue. Ductility, by definition, is a measure of how much the material can elongate before it ultimately breaks. So for the choices here, letter B is just the measurement, so it doesn't really relate to ductility. Letter C, tensile strength and yield strength, is just the ultimate strength and the yield strength and doesn't measure the ductility of the material. Letter D, toughness, is the resistance of material against impact. And letter E, fatigue, refers to the effect of the repetitive loads imposed to the material. So by definition that I've mentioned earlier, ductility is measured by how much a specimen elongates before it breaks, hence the reduction of area here. The higher this ratio, the percent elongation and reduction of area, the more ductile the material is. So the answer here is letter A. Who is responsible for verifying welding procedures have been properly qualified? Letter A, independent test lab. Letter B, contractor. Letter C, welding inspector. Letter D, architect. Letter E, engineer. So this question pertains to who is responsible for verifying welding procedures. So this is normally a job of a welding inspector. So for the choices here, the independent test lab is just responsible for testing the samples and providing a recommendation if it passed or failed. The choice for the contractor here is a bit general. So the contractor can do a lot of things here. So the architect and engineers are responsible for the design and not verifying the weld procedures. So the answer here is letter C, welding inspector. What MT technique could be used for the discovery of longitudinal flaws? So MT means magnetic particle testing. So letter A, coil shot. Letter B, circular magnetization. Letter C, longitudinal magnetization. Letter D, parallel magnetism. Letter E, using a central conductor. So coil shot here is when using a stationary empty machine and electricity passes through that conductor, the magnetic field is created. So longitudinal magnetization is produced from the yoke method as seen here. This is the yoke method. Circular magnetization is used to detect longitudinal flaws. Longitudinal magnetization is for transverse flaws. So if you use circular magnetization, you will not be able to detect transverse flaws, and longitudinal magnetization cannot detect longitudinal flaws. So the answer here is letter B, circular magnetization. Which code gives pre-qualified status to certain weld joint configuration? Letter A, API 1104. Letter B, AWS D1.1. Letter C, AWS D17.1. Letter D, NSI B31.1. Letter E, AWS B2.1. So let's just run through the codes here. So API 1104 is for pipelines of oil and gas and petrochemical industries. Mainly pertains to the welding of those pipelines. Letter C, AWS D17.1 refers to the specification for fusion welding in aerospace applications. So this is for the airline industry. ANSI B31.1 is for power piping. This is mainly for power plants. AWS-B 2.1 is for specification for welding procedure and performance qualification, standard for any other material with no governing specification. But this code does not give pre-qualified status. So if you have any material here that was not being covered by any other welding standard, you can use AWS-B 2.1. So the only standard or the only code here that gives pre-qualified status is AWSD 1.1, the welding code for structural steel. AWSD 1.1 welding code for structural steel gives pre-qualified status to certain weld configuration and is found in its clause 3. So the answer here is letter B. Information that appears to the right of the weld symbol refers to the A, process to be used, B, type of electrode to be used, C, length of weld required, D, size of weld required, E, required joint configuration. So let's run through the choices here. So what is the information that appears to the right of the weld symbol? So the process to be used for welding appears in the tail. It is indicated in the tail of the welding symbol. The type of electrode to be used can also be indicated in the tail. The size of the weld appears on the left, not on the right of the weld symbol. The required joint configuration can be indicated in the tail, but the weld symbol kind of implies this joint configuration. So the answer here is letter C. The length of weld required is or does appear in the right side of the weld symbol. The position on a metal stress strain curve referring to its changes in behavior from elastic to plastic is the letter A, yield point, letter B, modulus of elasticity, letter C, endurance limit, letter D, transformation temperature, letter E, Young's modulus. So for letter B here, modulus of elasticity is defined as the stress over strain. It is the slope here, as you can see, the slope of the proportional limit up to the proportional limit here. So it is just the slope of the proportional limit as defined by or as calculated by dividing the stress value over the strain. Endurance limit relates to the allowed repeated loads that the material can take. So if the material is subjected to repeated loads, thus under fatigue, this it can be or the endurance limit must not be reached in order for that material not to exceed its fatigue limit or not to experience fatigue failure. The transformation temperature is just the temperature that the metal will experience during its phase change. And the Young's modulus is basically the same as the modulus of elasticity. So the answer here is the point that uh, where the material changes from elastic to plastic is the yield point right here. So the yield point is where the material changed from elastic to plastic. So meaning if the load experienced by the material exceeded the yield point, it will no longer return to its original form, thus the plastic deformation here. So the answer in this question is letter A, yield point. Low hydrogen electrodes can be properly identified by which digit of a classification number? Letter A, first digit. Letter B, second digit. C, first and second together. Letter D, second to the last digit. Letter E, last digit. So this characteristic can be found in the electrode's last digit. Letter E. It is denoted by numbers 5, 6, or 8, which denotes low hydrogen or the electrodes contain low hydrogen characteristics. So the digits denote different identification for different welding processes, but the notation for low hydrogen content is still in the last digit. So the answer here is letter E. All welding symbols information referring to the arrow side of the joint is found A in the tail, B above the reference line, C below the reference line, D in a note, E to the left of the weld symbol. So the tail denotes other welding information. So for letter A, the tail denotes other welding information such as process, electrode, procedure, even reference drawings you can put in the tail. Above the reference line is for the other side of the joint, not the arrow side. So notes can be done in the tail as well. Left of the welding symbol typically denotes the size of the weld. So as you can see here, the arrow side, if the weld is on the arrow side, right here, it is below the reference line. So the answer here is letter C. Empty or magnetic particle testing can be used effectively to inspect which of the following metals? Letter A, welds on A36 steel. B, steel welds on stainless steel plate. C, welds on aluminum. D, welds on alloy materials. Letter E, materials properly qualified for use with E308 electrodes. So empty can be effectively be used for ferrous metals, in this case A36. So A36 is a kind of structural steel. Welds on stainless steel or welds on stainless steel plate might be problematic, especially for non-ferrous stainless steel because they lack iron. Or for austenitic stainless steels, for example, they don't have iron in itself. So magnetic particle testing will not work on that. Welds on aluminum definitely because iron almost is non-existent on aluminum. That's why it's not rusting, right? Empty will not be effective on inspecting defects or discontinuities in aluminum. Alloy materials here are a little bit vague here, but the rule of thumb is that the material must contain iron for empty to work properly. The last choice here is that E308 electrode is for low carbon material specification. This electrode is for low carbon steels, and this does not relate to the question being asked. So the answer here is letter A. Since empty will work on ferrous or will work effectively on ferrous metals, and A36 is a ferrous metal containing iron. The use of preheat on a medium carbon steel weld test plate will perform all of the following except letter A, reduce distortion. Letter B, reduce the possibility of hydrogen cracking. Letter C, result in the formation of martensite. Letter D, produce a wide heat affected zone. Letter E, diffuse hydrogen. So what happens when you preheat a medium carbon steel? Preheat can reduce distortion since the material will not result in sudden change in temperature. So if you preheat that material, when you weld it, it will not be subjected to a sudden change in temperature due to its exposure to the atmosphere, or if you subject it to post weld heat treatment. So for letter B as well, it will be to reduce the possibility of hydrogen cracking. So the material will have that reduction of possibility because cracks will not happen because preheat will improve its grain property. And because of a larger heat input, basically preheating will have a larger heat input on the material prior welding. It will produce a wider heat affected zone or HAZ. And since we have a larger heat input than normal, it will diffuse hydrogen because the heat will increase the kinetic energy of hydrogen molecules, thus increasing its speed and diffusing them to the atmosphere. So the answer here is letter C, result in the formation of martensite. So preheat will not result in the formation of martensite since these martensite are formed when rapid cooling of metals are done through like quenching as part of making the metal harder, but in its consequence making it more brittle. Martensite makes the metal more brittle because it results in a coarser grain structure when you subject the material in a rapid cooling phase after heating or after welding it. If you see the coarse grain structure that is produced by martensite, if you see it in a microscope, it resembles a broken glass. So it is somewhat synonymous to the metal being brittle. So the presence of paint can affect which of the following non-destructive testing. So that's basically what is being asked in this question. So the requirement of PT and MT is that the weld surface must be clean and that includes paint. So this presence of paint can cause false indication and the paint can also block the opening and thus the discontinuity cannot be revealed properly. So basically if you have a surface that is being blocked by the paint, then the discontinuity cannot be revealed. So the answer here is letter A. PT, and MT. Fracture toughness results often be expressed in terms of letter A, breaking energy, letter B, tensile strength, letter C, percent elongation, letter D, endurance limit, letter E, reduction of area. So for the choices here, tensile strength is the capacity of the material before breaking. This is indicated or located in the ultimate tensile strength in the stress strain curve, right? So we have it right here. So before the rupture point. So the percent elongation is also known as strain, or the ratio of the length and the original length. So this percent elongation is just basically the strain of the material. Endurance limit is the stress level below which a material can theoretically withstand an infinite number of cycles without failure. So endurance limit basically pertains to the fatigue or relates to the fatigue failure of the material. Reduction of area is the change in area when the material is subjected to tensile force. So can just imagine if you pull a material in its cross section, and eventually it will be reduced in its area. So the answer here is letter A, breaking energy. So this measures the fracture toughness of a material. So this can be measured by a bunch of testing procedures like CHARPY notch, IZAD, among those testing procedures. If no information appears to the left of a groove weld symbol, this means A, no weld is required on that side. Letter B, the weld is to be complete joint penetration. Letter C, the weld is to be continuous for the entire length of the joint. Letter D, beveling is not required. Letter E, weld size is to be determined by the welder. So when there's a size or a number indicated in the left of a groove weld symbol, it means that the groove weld does not fill the entire joint. So if there's no information, that just means that the weld is a complete joint penetration, which is indicated here in the choice letter B. So for the choices here, A is just false. So there is a required weld on that side of the welding symbol. C, for letter C, there's no information on the right side of the weld symbol. So for this one, if the weld is to be continuous for the entire length of the joint, then it must be located on the right of the welding symbol or the weld symbol, not on the left. So beveling and the weld size to be determined by the welder is false as well. So the answer here is letter B. So to summarize this question, if it is on the left, if there's no information on the left of the groove weld, then it is a complete joint penetration. If there's no information on the right of the weld symbol, then the weld is to be continuous for the entire length of the joint. The property of a material, the property of a material that best relates to its resistance to impact loading is letter A, endurance limit, letter B, fatigue strength, letter C, fracture toughness, letter D, tensile strength, letter E, ductility. Endurance limit is the stress level below which a material can withstand an infinite number of cycles without failure. So that relates to the fatigue strength, which is also letter B. So tensile strength is the capacity of the material before breaking, as indicated in the stress strain curve. Ductility is the ability of the material to be deformed or elongate before breaking. So the property here that best relates to the resistance to impact is toughness, fracture toughness. So fracture toughness determines the material's resistance to impact, most commonly with high tensile strength materials and for those materials that are exposed to the cold temperature. So the answer here is letter C. Of the following discontinuities, which is most likely to be a flaw caused during the manufacture of steel? A, porosity, B, lamination, C, undercut, D, crack, E, inclusion slag. So for the choices here, porosity occurs due to the moisture or the presence of hydrogen in the weld. Undercut is where a notch is formed by a metal being melted away from the weld zone. So a crack is a serious defect that can lead to failure. So as you know, there are no acceptable forms of crack. If you see it, it's automatically a defect. Slag inclusion is the inclusion of a material in the weld metal. So this can commonly be, be formed when there's not enough cleaning in the weld. So for letter B, lamination normally happens when the steel is flattened during the rolling process. So during the rolling process, it can be considered as during the manufacturing process of steel. So the answer here is letter B, lamination. Which of the following is considered to be an advantage of VT or visual testing? Letter A, discontinuities can be located and noted when they occur. Letter B, it is capable of detecting subsurface discontinuities. Letter C, welders can accept their own work. Letter D, equipment can be expensive. Letter E, it can determine material strength. So if you can observe here, all of the choices have their own merits, right? But we have to select the best answer here. So the big advantage of visual inspection is that it can detect a discontinuity before the welder puts on another pass in the weld. Just an example, right? So for letter B here, it is just not possible with the naked eye and without the assistance of other NDT methods. So you cannot detect subsurface discontinuities with your own eyes because it is hidden. So letter C, you want to avoid this. Welders can accept their own work because there must be an oversight with the welder's work in order for a proper quality control procedure to happen. Letter D, equipment can be expensive. So yeah, definitely. Equipment is expensive, but there are other defects that be best done by, for example, X-ray or RT or UT. Just an example. But this is not an advantage of VT because having different NDT methods have their own advantages, right? So this is not the main advantage for visual testing. So because there are other more effective NDT methods that are more appropriate for a specific kind of discontinuity to be detected. You cannot determine the material strength by just looking at it. So you have to, it needs to be tested or uh, for example, it must be subjected for under a tensile strength machine. You cannot determine it by just looking at it. So the answer here is letter A. Discontinuities can be located and noted when they occur. So that gives value to the uh, welding procedure or welding the entire welding procedure because you can detect the early signs of failure before it even or before it got it will be hidden because another pass of weld is done. So you can do that by having a hold point in the inspection test plan if that weld is to be a critical one. When a weld has been rejected by a qualified NDE technician, the welding inspector should letter A, review the test results and maintain the test record. Letter B, reinspect to verify the defect. Letter C, accept the weld if its visual appearance is in compliance with the applicable code or specification. Letter D, require another inspection by a third party. Letter E, accept the weld since it is in a low stress region. For letter B, no need to inspect if the weld has already been rejected by a qualified NDT technician. So this is just counterproductive already. So letter C, this is a big no because the code will not allow this in the first place. Because the first basis of weld acceptance are actual measurement of the discontinuity as you see it in the weld. Letter D is just expensive and unnecessary. So you don't need another inspection by a third party unless otherwise you have a dispute with the first NDA inspector. So that's just not very efficient or very cost effective. And letter E, we don't have enough information for letter E to be true. So the answer here is letter A. So this goes back to the responsibility of the welding inspector to review the test results done by the NDT technician and maintain the test records. So if there are any disputes or, for example, any code violation or whatnot that has been reviewed by the welding inspector, then he should take it up with the NDT technician. But if it is all good, because it is not stated in the question that there are any discrepancies, so the best answer here is letter A. If equal thickness of steel, cast iron, aluminum, lead, and copper are radiographed using the same exposure conditions, which material will result in the darkest radiograph? Letter A, lead. Letter B, steel. Letter C, aluminum. Letter D, copper. Letter E, cast iron. So this question will test your knowledge of the output of these radiographic films. So the less dense material will produce the darkest radiograph. This is why hollow points in the radiograph are also the darkest. Hence, there's discontinuity there. So if there are lighter points that you see there, lighter indications, so that means there are discontinuity, right, in the film. So if you are familiar with the densities of these materials, so you can know that the least dense out of all the materials here are or is aluminum. So the answer here is letter C. So the least dense material will produce the darkest radiograph among these choices. All welding symbols require which of the following basic elements in their construction? Letter A, reference line, arrow, and tail. Letter B, reference line and arrow. Letter C, reference line, arrow, and weld symbol. Letter D, reference line, arrow, weld symbol, dimensions, and supplementary data. Letter E, reference line only. So the only necessary elements of the welding symbol are the reference line and arrow. All others are just optional. You cannot call a welding symbol without these two elements. So the answer here is letter B. Of the welding processes listed below, the one most commonly having the highest deposition is A. OAW or oxyacetylene welding. Letter B. FCAW, flux cord arc welding. Letter C. SAW or submerged arc welding. Letter D. SMAW. Letter E. GMAW. So the answer here is submerged arc welding, SAW. Because out of all the welding processes, this has the largest deposition because of its setup and the characteristic of this process, as it is an automatic welding process, unlike the other welding processes that you can see here, which is either manual like SMAW or GMAW, which is a semi-automatic process, and FCAW as well. So SAW is also operated by a welding operator, not a welder, which is aligned to be it becoming or to be it being in to be with it being an automatic welding process. So the answer here is letter C. In this question, as you can see, the welding symbol does not have any indication of the number at the left of the welding symbol right here. So it doesn't indicate anything. Therefore, the answer here is letter B. The size of the weld cannot be determined in this welding symbol. Letter A does not make sense. Letter C is obviously incorrect. Letter D, if the welding symbol is not clear, the welder will definitely ask for the size here. Letter E, the size of the weld may or may not be found in the WPS. So the answer here is letter B. Welding symbol information provided in the figure below requires A. Field welding, B. Weld all around, C. A fillet weld, D. The use of shielded metal arc welding, letter E. All of the above. If you can observe the welding symbol here, so this symbol is the symbol of a fillet weld. This flag right here is a symbol for field welding. The circle right here is, or the circle right here represents weld all around, and the information indicated in the tail is SMAW, which means shielded metal arc welding. So the answer here is letter E. A shielded metal arc welding weld has produced in which the welder failed to properly clean between passes in a multipass weld. Which non-destructive test would best reveal the flaws that may be present in the completed weld? ART, BVT, CMT, DPT, letter AET. Since the welder failed to clean passes in between weld in a multipass weld, this indicates that the flaw will likely to have occurred in the subsurface of the weld. Visual tests will have no use in subsurface flaws. You cannot see that by the naked eye. MT and PT are for near surface discontinuities. ET is also for near surface. The only NDT here that can detect subsurface flaw here is RT. Hence, the answer here is letter A, radiographic testing. Which of the following welding techniques below describes a welding process in which the filler metal feeding is machine operated while the joint travel speed and guidance are the responsibility of the welder? Letter A, semi-automatic. Letter B, machine. Letter C, manual. Letter D, automatic. Letter E, mechanized. Machine, mechanized, and automatic welding are synonymous in which every parameter can be done without welder supervision. Hence, machine and mechanized welding have welder operator and not a welder. So because it basically operates a machine. Manual welding, the welder will have to control all parameters including wire feed speed because he basically will replace the electrodes once it was being consumed. Semi-automatic like GMAW, FCAW are the ones that the wire feed speed is operated by a machine. Basically, it is the wire speed is controlled by a reel. Hence, the answer here is letter A, semi-automatic. Arc strikes are discontinuities most commonly associated with A. ESW, B. SAW, C. SMAW, D. OAW, letter E. GMAW. Arc strikes commonly happen in SMAW or stick welding since this is mainly a welder error or a bad habit that the welder do prior striking the weld metal. They strike the surface to test and may lead to this discontinuity. So it is a common welder behavior wherein they strike the surface and thus cause this arc strike discontinuity. A and B are automatic process, so this will not happen. ESW and SAW. OAW is operated by a torch, which likely won't happen. GMAW can have arc strike occur, but not as much as SMAW. So the answer here is letter. So the answer here is letter C, SMAW. Liquid penetrant testing is not recommended when inspecting which of the following metals? Letter A, aluminum plate that has been chemically cleaned. B, steel weld test plates brushed. C, stainless steel pipe as welded by GTAW. D, a casting that has been sandblasted. A and B is okay, and B is even recommended prior dye penetrant testing because basically you have to clean these weld surfaces in order for dye penetrant testing to be accurate. So it basically keeps the opening of the surface, which is necessary for capillary action. C is also good since austenitic steel can still be detected by PT. So if you're using magnetic particle testing for austenitic stainless steel, you can do that because it can't be magnetized. The answer here is letter D. Since sandblasting breaks off or pin the surface that can close necessary opening in the surface necessary for capillary action. So if you sandblast the surface of a metal, basically dye penetrant testing will not be possible because you basically broke off all the openings there that is necessary for the capillary action or the liquid coming or rising to the surface to occur. So the answer here is letter D, a casting that has been sandblasted. Which of the following discontinuities is not associated with GTW? A. Lack of fusion. B. Slag inclusions. C. Tungsten inclusions. D. Porosity. E. Undercut. All of the discontinuities mentioned above can happen to GTAW except slag inclusion. Letter B. Since GTAW is very much a clean welding process with little to no slag produced during the welding process. The answer here is letter B. An E71T-1 electrode designation is for which welding process? Letter A, PAW. Letter B, FCAW. Letter C, SMAW. Letter D, GMAW. Letter E, SAW. So the answer here is letter B. The designation T here means tubular, which is the electrode description for FCAW or flux cord arc welding. So the answer here is letter B. What is meant by the term essential variable? Letter A, data on a WPS that if changed during production will render a WPS disqualified. Letter B, data on an inspection report that if changed render the report disqualified. Letter C, the data on an MTR or material test report that is essential to the chemistry of the material. Letter D, the recommended amperage and voltage for welding as published by the manufacturer. Letter E, describes what should be included in a WPS. So let me run through the choices here. So letter B and C is an automatic elimination of the choices since this essential variable refer to the WPS. WPS can indicate the recommended amps and volts for welding, but this is not the definition of an essential variable. So basically, you can indicate the recommended amperage or voltage from the welding as published by the manufacturer, but this is not the definition of an essential variable. Letter E, those are not just what's needed to be included in the WPS. So the answer here is letter A. If these essential variables change, then the WPS will be disqualified and you will need to requalify the procedures indicated in the WPS again. So you'll need to retest those procedures that was done or the results of the procedures that was done during the original WPS and the variables that was changed. Where should the preheat temperature be measured? Letter A, in the weld groove. Letter B, 12-inch from the weld groove. Letter C, where the arc will be initiated. Letter D, 2 to 3-inch from the weld groove. Letter E, preheat temperature need not be measured. So the preheat temperature needs to be measured 2 to 3-inch from the weld. So the answer here is letter D. This is because this is where the HAZ or heat affected zone is, wherein the highest susceptibility of martensite formation can happen. So what does that mean? So HAZ refers to the portion of the base metal that has been heated to high temperature but not melted. So when it cools off, it basically undergoes the base metal undergoes a microstructural change that can affect its mechanical or material properties such as strength and toughness. So martensite formation can lead to the brittleness of the base metal, which we don't want that. So when no preheat is used, HAZ is relatively narrow and will exhibit the highest hardness. So as a welding inspector, you need to inspect the preheat temperature at the HAZ or in the heat affected zone because this is where the highest brittleness will happen. This is why this is the location where the preheat temperature must be measured to ensure that effective slowing down of the cooling rate happens in the heat affected zone, because essentially that is what preheat does to the base metal. So it slows down the cooling rate of the base metal, hence will slow down also the formation or prevent the formation of martensite, hence prevent brittleness of the base metal.